Hello friends, today we are going to discuss algorithms and flowchart. Okay, so algorithm and flowchart, these are general terms. You can find these terms everywhere. Getting? They are not specific to any single programming language. Okay, so you can make use of these algorithms and flowchart in every programming language. So first we'll see what is meant by algorithm, then we'll see what is meant by flowchart. So let us start with algorithms and flowchart. Algorithms and flowchart. Algorithms and flowchart. So first we'll discuss about algorithms. So this algorithm term is coined by Persian mathematician whose name is Abu Zafar Muhammad ibn Musa al-Khwarizmi. So he was Persian mathematician. This term was invented by Persian author or mathematician whose name is Abu Zafar Muhammad ibn Musa al-Khwarizmi. So he was a single person whose name is this one, Abu Zafar Muhammad ibn Musa al-Khwarizmi. So this is the person who is responsible for this algorithm term. He coined this term. Okay, and professionally he was a mathematician. Okay, so that's why this algorithm concept come into picture. Okay, now we'll see what is mean by algorithm. So algorithm is generally, they are the steps. Algorithm, they are the steps, but these steps are finite. Okay, and these steps have some meaning. Okay, so see, these are the some important things about algorithm. Algorithm, these are the steps. These steps are finite. They have some meaning. That means they are well defined, and very important thing, these steps should be in sequence. Now what is the use of all these things? Generally we are going to solve some problem based on these things. So algorithms must be written to solve a particular problem. So suppose you have some problem definition or problem requirement, then to solve that problem you must write algorithm. So once you write algorithm, then it is easy for programmer to write program. Getting? So first we'll see what is definition of algorithm. So algorithm, these are finite set of well defined steps. Algorithm is finite set of well defined steps, and these steps are in sequence. Okay, to solve a particular problem. To solve a particular problem. Getting? So this is the important definition of algorithm. Algorithm are the finite set of well-defined steps in sequence which are written to solve a particular problem. So see, algorithms are finite. They are the steps. These steps have some meaning. Okay, so that's why well defined, and these steps should be written in sequence. Okay, to solve a particular problem. So this is the simple definition of algorithm. Getting? Now every algorithm must have some properties. Okay, or every good algorithm must satisfy some properties. So now next point is, which are the qualities of good algorithm? Which are the properties of good algorithm? So we'll discuss those properties. So properties of good algorithm. So there are different properties of algorithm. So we'll see these properties one by one. Getting? So properties of good algorithm. So first property is input. First property is input. So every algorithm must have 0 or more input. 0 or more input. every algorithm can have every algorithm must have 0 or more input. That means it is possible that some algorithm may have 0 input. It is possible that any algorithm has 0 input. Second property is output. Second property is output. So every algorithm should have one or more output. One or more output. So it is possible that some algorithm may have only one output, but there should be at least one output. There should be at least one output for some algorithm. Now third property is finiteness. Finiteness. Getting? So what is meant by finiteness? So your algorithm should end after some steps. Algorithm should have some ending point. It should terminate after some steps. Getting? So it should have some end point. Algorithm should not be infinite. It should be end after some steps. It should have some terminating point. Getting? So that's why finiteness. Next one is definiteness. Definiteness. Algorithm must be definite. Now what is meant by definiteness? Your algorithm or whatever steps you are writing in algorithm, those steps should be clear, those steps should be precise, and those steps should be unambiguous. There should not be any ambiguity in those steps. So that is nothing but definiteness. Each step in algorithm should be clear, precise, and unambiguous. There should not be any confusion to the reader of algorithm. So that is nothing but definiteness. Now next property is effectiveness. Effectiveness. So algorithm should be effective. That means your algorithm should solve some problem. Getting? So algorithm should be written in such way that it should be effective to solve a particular problem or to solve a given problem. It should be effective. Getting? And it can be converted in any programming language. There is no any condition. That means your algorithm should be written only this programming language. It can be converted in any programming language. So algorithm should be general. Algorithm should be general. So it should be effective and you should solve a given problem. So that is effectiveness. Next property is your algorithm is different from programming code. Your algorithm should be different from programming code. Getting? It should be different from programming code. So these are important properties of good algorithm. Getting? So every good algorithm should satisfy these particular properties. So you should remember these properties whenever you are writing algorithm. So see, I am repeating. Suppose you have one problem statement, then you need to write algorithm for that. Getting? And then this algorithm will be given to programmer. Getting? So programmer will understand this algorithm and based on this he will write program. Getting? He will write program. Getting? So we'll see one simple example of algorithm. Getting? So we'll write algorithm for addition of two number. We'll write algorithm for addition of two number. Algorithm for addition of two numbers, and these numbers we are taking from user. So see, algorithm, these are the steps. We have seen algorithms, these are the steps. Getting? So first step is start. Getting? First step is start. These are the steps. So algorithm should have some starting point. Next, see, we are going to perform addition of two numbers. Getting? So we are going to read these two numbers from user. So we'll require some variables. So we'll require, see, variables. Getting? So consider I am taking number 1 and number 2 variable. Getting? So first value will be read in number 1 and second value will be read in number 2. Now in addition to these two variable, we are going to store result in some variable. So I will write result variable. I will declare result variable. So see, I am declaring 3 variables, number 1, number 2 and result. So this is the second step. Now what is third step? See, we are going to read two numbers. We are going to read 2 numbers from user. So read number 1 and number 2. See, we are going to read 2 numbers, not result. We are going to calculate this result. Getting? So this is third step. Next step is compute result. Compute result. Now how we are going to compute this result? So what should be formula? So see result and see arrow operator. So you know that the evaluation will be done. First right side evaluation will be done and that result will be assigned to left side. Okay. So what should be formula? Whatever number you have read in number 1 and number 2, they will be added and that result will be assigned to this result variable. Getting? So this will be result and you got result. Now what is your job? You need to print this result. So you need to print the result of addition. Getting? And last step is stop. So see, this is simple example of an algorithm which calculates addition of 2 numbers which are entered by user. So this is simple algorithm. Okay. So this is an algorithm concept. We have discussed about algorithm. Then it's a properties, important properties, and we have seen one example of algorithm. Now we will discuss about flowchart. Okay. Now when flowchart concept come into picture. Now see again the same scenario. Suppose you have one problem statement with you. Now you are going to understand that problem. Okay. And once you understood that particular problem, then your job is to write algorithm. Getting? Just we have seen algorithm. Problem is addition of 2 number. We are going to write program to that program will find out the addition of 2 number. So for that purpose we have written algorithm. So first step is take problem statement, understand that problem statement, then based on that understanding write algorithm and then give that algorithm to programmer so that programmer can convert that algorithm to program by using some programming language. That programming language can be C, CPP, Java, C#. Getting? But see, this is a very simple example of algorithm. But sometimes your problem is complex problem. Getting? There are so many confusions in problem statement. So suppose after some try you have understood that problem statement and you have written or you have framed one algorithm. Okay. But see, that algorithm is very complex and suppose you have handed over that particular algorithm to programmer. Now see, problem arises over here. Suppose that programmer or developer, if those people are unable to understand your algorithm easily, then in this case what you can do, you can go for flowchart. So flowchart will help those developers to understand algorithm. Getting? So flowchart will come in between algorithm and program. So if those programmers are unable to read or unable to understand your algorithm, which is very complex, so in that case you can draw flowchart. So flowchart is nothing but it is diagrammatical representation of algorithm, or it is graphical representation of algorithm. So program is flowchart is easy to understand your algorithm. Okay. So flowchart will be in between algorithm and program. So definition of flowchart is it is graphical or it is diagrammatical representation of algorithm. Diagrammatical representation of algorithm. Getting? Okay, diagrammatical representation of algorithm. So there are some symbols which are involved in flowchart. So first we'll see those symbols and then we'll see one example of flowchart. So which are the symbols used in flowchart? Which are the symbols used in flowchart concept? So first symbol is in flowchart is arrow. This arrow, getting, or you can get like this. So the meaning of this arrow is it is used to represent the flow of logic. It is used to represent the flow of logic. Okay, so from this point the data will be given to this, getting like this. So flow of execution or flow of logic, it will be represented by this particular arrow operator. Now next one is this symbol. Okay, so this symbol is used to represent the start and end step. Starting and ending point will be represented by using this symbol. Getting. Next, parallelogram. So parallelogram will be used to represent the input and output. Input and output will be represented by parallelogram. Getting. So these are the three. There are other symbols as well. Next one is there will be rectangle. So rectangle will be used for simple statements or processes. So processes are represented by using rectangle. Next symbol is diamond. Next symbol is diamond. So diamond is used to represent the conditions. Diamonds are used to represent the conditions or representing the decisions. Getting. Decisions. And last one is simple. It is a connector symbol. It is a connector symbol. Getting. So generally these 6 symbols are mostly used in flowchart concept. So you should use this you should use these symbols in flowchart. Getting. So while drawing flowchart you should use these symbols. Okay, so now we'll see that same example, addition of 2 numbers, okay, using flowchart. So addition of 2 numbers and those numbers are entered by user. Okay, so what was first step in algorithm? That was start. So for start you should use this symbol. Getting. You should use this symbol. So this is what start. So start step can be represented by using this particular symbol. Now what was next step? Step second in algorithm, it was declaring variable. So declaring variable is what? It is statement. Declaring variable, it is what? Statement. It is a process. So see, you should use rectangle. We have declare variables number 1, number 2 and result. Getting. So that was what is next step? After start it is declaring variables. So number 1, number 2 and result. Getting. What was next step? Yes, there was what? Reading number 1 and number 2. So see here you are reading input. Here you are reading input. So you should use parallelogram. So see, read number 1 and number 2. So reading input. Okay. Now after reading, what is the next step? See, you should calculate the result. So what is the formula? What was the formula? Result. Okay. Number 1 plus number 2. This was statement. This is regular statement. And after this, you need to you need to display result. Okay, so you need to print result, and last step is stop. So see, the flow of logic will be gone from start to stop. Flow of logic will be went from start to stop with this sequence. So this is step 1, starting, this is starting point, then we are declaring 3 variables. So this is statement or this is process, so it should be represented by using rectangle. Getting? Then you need to read values, so you need to read input, so there should be parallelogram. Then there should be process, that is you are computing the result. Okay, so that's why there should be rectangle. And now you got the result, your job is to print that result, so you should use parallelogram, and then there should be stop, or there should be end point for your flowchart. Okay, so here in this session we have discussed about algorithm and flowchart. About algorithm we have discussed different properties, and here we have discussed how to make use of these symbols in flowchart. Okay, so like this you can also write algorithm for complex problems, and you can also draw flowchart for complex problems. So these two things will be help programmer to write his or her program. Okay, so if you like this video, then please like, comment and subscribe to my channel Programming in My Way. Thank you.